Good morning, my dear students. On this Happy Teachers Day, 5th September 2024, as being I'm your mentor, I wanted to educate you guys in a practical way. You see, here, what exactly I'm trying to make you understand. You're all doing a lot of projects, but without knowing anything about the power supply required for all of your projects. So I have tinkered this power supply unit today. You see here the power supply what I made it's a not regulated one, unregulated one, but make you understand because during my childhood days, a lot of gadgets used to work like my radio and all on battery, so they're expensive at the time. So we wanted to convert that electrical alternating current, this 230 volts AC into 12 volts DC, something like that, so that my radio works without the battery. So this whatever incoming voltage, the utility line power at our homes like 230 volts, so that can be converted here, as AC to DC conversion. But however, if we just use the rectifier, then 230 volts will become to 220 volts DC. But we want 12 volts DC. That's why what we did, we have used a transformer here. Okay, this is a step-down transformer. It will have primary and secondary windings. So primary we will connect to the phase neutral 230 volts coming to our homes, and because of the mutual inductance in the transformer, because there is a magnetic coupling, so there is an induction taking place from the primary winding to the secondary winding. That and all I will explain you how the transform works in another video. So when secondary windings are wound in such a way, the number of turns chosen from the primary to second, because you all know the formula V1 by V2 is equal to N1 by N2. V1 by V2 means the primary voltage V1 and the secondary voltage V2. So depends upon the ratio of the turns of the primary and secondary. The ratio here is, suppose say N1 is the primary number of turns used copper winding, and N2 is the secondary number of turns. So V1 by V2 is equal to N1 by N2. With that formula, you can choose the ratio to be wound for whatever voltage you wanted on secondary. So here I just wanted to have 12. I wanted to go for a full wave rectifier. That's why on the both of the 12 connections I have used diodes, that 1 and 4007, and then the cathodes, both of them cathode short circuited at a point, and also I have taken the 0 point of the transformer to output, as a negative, and both the cathodes wherever they joined, I have taken it as a positive, and also I have used one resistor and LED, so that you will know whether the DC output is coming or not. But I can't connect directly LED to the 12 volt. That's why I used a resistor also. So the anode of the LED is getting connected to the positive of the DC source, and the cathode is directly getting connected to the zero line. The ground one. Okay. So with this, I also used a filtering capacitor. Okay, 1000 microfarad by 25 volts. I have used one filtering capacitor also. Then finally, I have provided outputs. You see, the red and black for your DMM measurement, and then female sockets to take out the power. I'll show now with this kind of some loads and the voltage measurement, current measurement, all these small gadgets I have developed to show you all this now. So, happy Teachers Day, happy tinkering, keep innovating. So let me show you some measurements, and then you will see how I have tinkered today on this Teachers Day, 5th September 2024. Okay, so I'll get back to you in another half a minute. See, my dear friends, I have connected few LEDs on my power supply, 12 volt DC power supply. Okay, so they are glowing. But we wanted to know what is the output voltage and what is the current the load is pulling. There are near about 12 LEDs glowing now. Okay, so we need to know all these LEDs, how much current they are pulling, and then we can also know Once we know the voltage and current, then we know how much power is getting consumed, electrical power is getting consumed, and then later, with respect to time, how much energy is utilized. That also we can come to know. So let me connect you to my tankard, a small voltage and current measurement device. Okay, stay tuned. Now you see, my dear friends, I have connected my tankard, the voltmeter and current meter in series to my load, and I can see the voltage, of my unregulated power supply is 18.3. But however, that is because no load, because capacitor charge also is included. That's why it is showing you that much. Okay. Now I am going to switch on the load through my this tankard meter. Now you see the load is on. Because the load is on, the voltage has come down to 13.1. But however, it also shows you the current, 0.32. So you can multiply the 13.1 multiplied by this 0.33, then you will get the power getting consumed by these bulbs. Okay. So who is going to do the math? So do it faster. 13 into 0.33. Okay, that's good, nice. Okay, so likewise you can always understand, okay, the things, how they work like. Okay, that's good. Now let us go for the next point, because some student asked me, sir, can we reduce the power? I don't want this much of brightness. So whenever I need more bright, I will, fully utilize. But whenever I just want to dim them as a bed lamp, so why do I need to waste that much of power? That is one particular question given by one of my students. So for that, I have tinkered. Next level is just adding a voltage regulator in between, variable voltage source. Okay, I'll do that. It's a power controller. So I'll connect that also and show you that. You see, my friends, I have included another tinkered gadget in between. So earlier there is only unregulated power supply, this one. Now output of this one, I have taken it to input of my VI meter, voltage and current, and from there now I have connected my power controller. Okay. So from this, so what happening from this, the load is getting connected. Now it is working at full, that's why you can see the 0.33 amperes. But now what I am going to do, I am going to reduce the power. You see here, I can reduce the power. See, they are dimming, and at the same time current is also going down. You see, when there is no load, the voltage went up because no load voltage. Okay, but when there is load, I am increasing the voltage to the load, they have started pulling current. That's why the voltage has come down, and because load is there. Okay, so this is how the current pulling and voltage variation and all these things you can understand. Then you can calculate power at any time, because if I totally dim it, then you see very less power it is consuming. My LEDs are consuming very less power. But if I am going for full and in between somewhere, then they are just drawing 0.2 amperes. But when I am going for full, then they are drawing 0.35. So you can always multiply the voltage and current. And so I hope you understood the engineering schematic drawings and boards from the books, whatever, in this demonstrative way. So the region I have taped here, this is 230 volts primary, so we shouldn't touch it. Here I can touch, there is no problem here because they are 12 volts, okay? But that's a secondary. That's where I have taken rectifying and then filtering and whatnot. I've already explained earlier. So for this day, now actually all these things I'm trying to visualize how the stuff works for my 10th graders dealing the electricity in a practical way. I've developed such kind of many gadgets for children understanding all the concepts of physics like sound, heat, light, electricity, whatnot. Okay, so let's enjoy tinkering. Happy tinkering, keep innovating. This is your Srinivas signing off from scientificstudents.com/tinkermasters.html, scientificstudents.com/circuitlab.html. Happy tinkering, keep innovating. Happy Teachers Day. Skill India, School India. Skill India from School India. Made in India, Make in India. Jai Hind, Jai Bharat. Jai Kisan, Jai Jawan, Jai Jai Vignan. Happy tinkering. Signing off, your Srinivas. Bye bye.